name is RStudio, one of the Science Gateway managers here at HUBzero. Claire is also online. Today, and welcome to the community meeting, we're going to talk about RStudio and the HUBzero platform. So I'll go ahead and get started here. A small agenda. I'm going to start out with what is RStudio, what are some prerequisites, kind of hinting at that RStudio uses R. How do you import data? How do you transform that data? Just some basic examples, and then into plotting and visualization of your data. Again, just a few examples, and then a little bit about Shiny apps, because that's one of the newer, cooler things. And then I'll briefly show you where I usually find some resources and some tricks and tips out there. And then I'll do a short live demo walkthrough of what RStudio looks like on the hub and how you would access that, and how things may be a little different than if you're using RStudio, let's say, installed on your workstation. But as far as the scope of the presentation, it's meant to be kind of some short examples, giving you an idea. I won't go into depth of, how R works too much, or some of the, more extensive examples. So what is RStudio? Okay, so RStudio is an integrated, an IDE, essentially, for those who are familiar with that. When I first learned R, I used the standard R GUI that's available on the Mac. RStudio is much more user-friendly, and you can see on the image here that it really gives you a view of all the pieces that you need to know about when you're working with your R code. You have your source code, you have a console so you can run the R code, you have environment global variables that are listed there, and you also have a list of files that are in your working directory. You can look at different plots, look at different packages. I'm looking at down here in the bottom right box here. In particular, and I'll mention some things about packages later on, those are what extend R to do cool Shiny apps or other cool visualizations and data manipulation and that. So RStudio server is available on the hubs with the most current middleware. That comes along with your Jupyter notebooks as well. So any examples I show here are very basic, and really you could use RStudio or a Jupyter notebook. It depends on which interface you really like. Okay, so like I said before, the prerequisite is really to know R. RStudio is not going to teach you R. You're going to have to know some of those commands and be familiar with the terminal. So, but what's nice about RStudio is that you can copy and paste commands into the interface and it'll run for you. So you're not writing the script in a text editor somewhere and then, okay, now I'm done making changes and I have to go run that script. You can run it very quickly from RStudio. But to back up a little bit, so in any case, you need to know R. I thought I'd show a quick example of a histogram in R and how that works. And this is, if you don't know R, kind of how it works a little bit. So you can see in the upper right-hand corner here, addition is very easy. This is your output. You can compute a logarithm. You can print text. You can do multiplication. R is really designed to get a data set, manipulate that data set, and generate plots or some type of visualization for that very easily. So it is the fact that you can just say 1 + 1 and R knows what that is eliminates some of the lower level issues you have to go through. I wouldn't say issues, I guess. With some programming languages, you have to define variables and define memory and things like that. R, you do not. So, importing and transforming data, this is where it gets fun rather than doing your basic computational stuff with R. In this example, just a sense of data set, this is one of your typical R examples. You can download the data set directly from pretty much anywhere. It could be in your home directory, it could be on your desktop, it could be on a website. And it'll read that CSV directly in and set it to a variable. You can see here on the right-hand side how RStudio displays that when that command is run. It shows you the data set here at the top left, shows you on your right, top right, what the environment variables are. There's no plots yet on the bottom right, but on your console, you can see that the command's run, the variable has been created, and it's waiting for the next command. So it's as simple as typing in that string and then hitting enter, and then that gets downloaded. Okay, so now that you have that data set, what can you do with it? You know, transform the data a little bit. Maybe you just want to know a few simple little things. You know, if you've ever, you know, if any of you are a data scientist or if you manipulate data, a lot of times the first questions you're asking are, well, what's the average? What's the maximum, minimum? You know, what are, you know, just those basic metrics that you want out of a data set. And that's really easy to do in R, and in particular RStudio. So you can say, you can choose a column by name. You can set it as a vector. But these here at the bottom of the text for determining the median, variance, standard deviation, the mean, you can see on the right-hand side, that is really just a matter of entering that in the console. So you can see max, your data set, and then which column you want. You can see the columns on the upper left-hand side of RStudio, and it just it prints out the result for you. Now you can get a little more advanced, and you can set that to a variable. So a lot of times, if you have a large data set with a lot of columns, you may want to kind of trim that down and do some calculations at the same time. You can do that and then save that to a new data set inside a new variable. So you just have to remember when, after you're done with the variable, you have to write it to a file. All right. Plotting and visualizing data. Let's see here. So again, with the same data set, the command is pretty simple. You just say plot, what's your X and your Y, and what type it is. And of course, this can get much more advanced. You can get different titles. You can get all kinds of different plots and graphs. But as a basic example, you can see here in RStudio, the data set, the command that's being run, and then the plot on the bottom right-hand side. So in one command, you're getting a basic plot. Where I know in some other languages, or even to do that in Excel, there's a lot of clicking around. And that's a good comparison as well, is a lot of people that run statistics still do that in Excel. When you get into very large data sets, that's near impossible to do. I've actually run into some cases where Excel won't let it load a data set because it's too large. So that's where R comes in. You can do some of the similar things in Python and other languages. R just happens to make it very, very easy, and it's focused on that large data set manipulation and getting metrics and usage out of that very, very easily. Okay, so our Shiny apps. Before I go on there, let's see, looks like I have one question in. The Swirl package, where you can run the Swirl program, which is a tutorial to teach R instead of RStudio, is pretty good. Actually, I'll use that when we get to the demo in a little bit here. So thank you, Anne. I know I went through that pretty quickly. Does anybody have any questions about kind of the basics of R and how you can enter those in RStudio and get a result?
We do have one question. Why would you pick RStudio over, say, Python Notebook?
Which language you would like, or you're more familiar with, or you like to use better. So when I first started learning R, I started with the R GUI that's in the Mac, and as things grew larger, was easier for me to write an R script and then modify that and just run the R script. RStudio for me is more of a teaching tool, or for demos, or for quick little projects. But as things get more extensive, I really need scripts that I can version and Git and things like that. So it's really your preference. I know a lot of programmers like to have an IDE, and then they save their file somewhere, and then they, like in their home directory, and then they version it there. I tend to work directly off the file system, but that's my preference. The last major project I worked on that involved this type of data analysis, we actually used R and Python. Some of the Python packages, they're a little easier to use depending on what your goal is. So I would say use both, or if you like one or the other, use that. It all depends on what you're doing. To be more specific, data wrangling was easier to do in Python for our data set, and then for one data set, and then another data set was so much easier to do in R. The more complicated stuff, I needed some of the Python packages to do that with. So hopefully that answers your question.
Yeah, also kind of a follow-up one. I know Jupyter Notebooks or a notebook, there's a little bit more flexibility to kind of copy a notebook if you have the right access. If you use a notebook in a HUBzero environment, you have that ability, depending on if the developer stripped out those options, of course. But do you have similar options with RStudio to kind of have that capture, copy, edit, or rearrange cells as freely as you do in Jupyter Notebooks?
Don't think so. Yeah.
So that might just be like even another comparison, right? Is that Jupyter Notebooks is a little bit more interactive and community engagement, whereas RStudio is more of the, standard what you expect a tool or simulation to look like.
Right, yeah, and that's a good thing to distinguish too, is that your RStudio is an IDE, and that's a very different concept than a Jupyter notebook or a Python notebook. Yeah, you're not going to get that flow of, I can run this section of code and get a result, run this section of code and get a result. You can recreate that in RStudio, but you're not going to be able to, just drag and drop it and manipulate it like you would. So depends on what you're doing.
All right. I'll let you proceed.
All right. So our Shiny Fs are actually really cool. If any of you have used Warframe Alpha, it kind of feels like that a little bit, where you're building they're more of a web widget than a web application. So I will mention that. So that's kind of what Shiny is. Shiny Server is part of that, and it is a R package. And so this is where I want to talk about R packages a little bit. And the person who asked about Python knows very well about different packages, but R is very extensible. Out of the box, R does its basic set of features, but you're probably going to need to install a number of packages, and one of those is Shiny. So this, the plot that I have here, well, interactive plot, I should say, is one of their standard examples. It's a movie explorer, and it is interactive. And I'm not going to show you this demo. I'm going to show you a different one, but this you can find on the RStudio website. Those sliders where you can filter years, minimum number of Oscar wins, dollars at box office, the plot on the right-hand side changes immediately when you change that slider. So as far as trying to visualize your data, and not only that, but you could interact with your data, that's a huge advantage for a lot of people. Again, looking back at a lot of data is being analyzed in Excel. They generate a plot, but it's a static plot. We're now getting, or have been to the point now where technology is looking at data to be interactive, so you can make better determinations with your data. So here's another example, and I want to talk about the structure of a Shiny app because it is a bit different than just running commands. It's still running commands, but there's other requirements than just running R commands and getting a plot. Like that example I showed before, you run the plot command with the correct parameters and you get a plot. Shiny apps are a little more complicated than that. This is the example I'm actually going to show you later on in a few minutes here. But there are three main components of a Shiny app. You have to have a code section for the user interface object. You have to have a server function, and then you have to call the Shiny app function, which is usually just one line. So I see it as a lot of times you have three chunks of code that has to be there, and then one to call both of those and run it. Okay. The cool thing about Shiny apps, and we've already done this with a couple of hubs, they can be created as standalone tool widgets. So those of you familiar with a hub, you go run a tool, and then you can interact with the tool. With Shiny apps, all you have to do is write the R code, include the R code in an R script, and we'll help you set up the proxies that are needed for that, and then your Shiny app, which is a web app, will be displayed as a tool, which is very different than Linux tools. So step into the modern version of that. So let's do a walkthrough of the hub. Jump out of the presentation here. So I'm going to use cubes here. You can see they have RStudio IDE for R tool installed. It has the same resource page. It has the launch tool button, which I've already started. So this is what RStudio looks like. You can see, because it's an IDE, it's going to look kind of like a desktop app, but a web page. So you're still going to find your file where you can create new files. Here's an R script. So you can open files. Here's another way to import a data set. So earlier I showed the command to download a CSV and save it to a variable. You can do that from the menu as well. Okay. So edit's pretty standard edit you would find in most programs. Code, sourcing different R files, that's another thing you can do. So if you have custom R code that you've written that you want to load before you run additional code on top of that, that's possible as well. All right. Plots, session. This controls your R session. A couple times I've frozen up the interface just because I did something dumb in R. I've had to restart R, and that's really easy to do. So there's not no fear in kind of going out in the wild and doing just about anything. You can easily reset the interface. You can also save and load the workspace. That's something that's common in R as well, but it's very easy to do here from the menu. A little bit of debugging, profiling, tools. So I'm skipping some of this because I really haven't used it. Most of it, kind of like I was saying before, is you use the interface, you create your R, your R Shiny widget or your R program, and you end up saving it, and it goes out to some production environment. But packages are a big deal, and I want to kind of show that a little bit. So usually, if you click on packages here on the right-hand side, it'll take a second to load, and it'll show you all the packages that are loaded. Now on the hub, there's a number of packages preloaded in this version of R. If you need another package installed, we can install it globally for everyone. You can also install that in your home directory. And by default, if you try to install a package here, It'll pull from the CRAN repository or from a tarball if you have that. And you can see it'll store it in the R directory in my home directory. So that's okay too. You just have to remember if you're deploying a tool with that code, eventually everybody can't see your home directory, so we'll need to install that globally. Let's see. Go down a little bit here. You can see Shiny is already installed. I was using it earlier, actually. But you don't have to use this interface. You can also go up here to Tools, click Install Packages, and you'll essentially get the same menu. So there's multiple ways to do things. One best practice is if you install things from the interface here, make sure this is checked to install dependencies. I've made the mistake of not doing that, and then you end up with kind of a weird broken package sometimes because you expect things to be there and you didn't install the dependencies, but that's okay. All right, so I'm going to take a brief pause right there and ask you if there's any more questions, and then I'll show you the Shiny example and how that works.
Well, at the moment, it doesn't look like we have any questions. Oh, Carol Song, do you have a question?
Yeah, so I'm wondering, is this tutorial or demo available somewhere online?
It will be right after we complete the demo. We'll share the slide deck and then the additional information collected through the webinar. It'll be all posted in YouTube and then also in our documentation on the Help Center.
Okay, great. Because I've got people asking me about this, and I was just looking for a place to point them to.
Yeah. I'll follow up with you afterwards so you can give you direct links if that's even one better.
Great, thank you.
Any more questions? If not, we'll go ahead and let Eric proceed.
Okay. So rather than typing stuff in, I'm going to just copy and paste this Shiny example in. You can see, you can do that. You don't have to copy and paste it in line by line. R understands that new line returns. So I'll talk through this code just a little bit. It loads the Shiny library. You can see that the UI variable UI object is being created. Okay. It's assigning output. We see the next section where it assigns this. Using a plot function, just generating the different. You can see that it pretty much uses the typical R commands. So if you want to make a histogram, use a histogram function, and it'll make the histogram. You just have to feed it the right data. The only difference in the Shiny app is that you have some things split off into the UI and other things split off into the server part. And then run the application, like I was saying before, is really just to run the Shiny app command and give it the server and the URI objects. So when I hit enter, I get a new window and I get the application. So if I move the slider, the chart changes for me. I want 1 bin, well, that's not very helpful, 3 bins, or all the way up to 50. Usually somewhere in between is good. Again, depending on your audience and what they're looking for in the data and what kind of ranges they're looking at. Now, for a Shiny app, basically this application you're seeing in this window is what would get published as a Shiny app for a tool. So just like you would go to a tool here, say launch tool, you would get the new window that would look like this. Maybe not exactly the size of your browser size, but so your Shiny widget can really be very complicated, very large. Let's see here. showed the movie example earlier. Since we have a few more minutes here, I'm going to, this one's kind of neat. I want to close this example. If I load this Genome Browser, and this is where it gets into some of the research area, rather than just doing fun analysis on movies or tweets or something like that. We actually have one hub that analyzes Twitter data over the last week by keyword, which is really cool. But anyways, this was focused on it's a genome viewer for pancreatic cancer. And you see this one, it's a little more interactive. As I click on things, I either have a pop-up that tells me what it is, or you can see how I can manipulate the chart a little bit. I can also change to a different donor, changes immediately, change the resize factor. That doesn't change much. And here's a bunch of options. So you can see this is something I could absolutely see with a unique data set, of course, on the hub as a Shiny app or a Shiny widget. You're going to get this web page. You're going to have all these different options that you can, I have no idea what I'm doing, I'm just clicking around. But you can see how you can draw some conclusions up from this data set pretty quickly because it's interactive. So, any questions about the live demo that I've shown? I've hit the key points I thought were important, but maybe I missed something, or you guys saw something, you're like, hey, what's that thing over there? If there isn't any questions, I'll go back to the presentation. Okay, so some tips and resources. I've mentioned a few best practices or tips throughout the presentation, but I wanted to stress that R and RStudio have a vast collection of resources available to you. I listed a few here. You can see a lot of them are just from RStudio.com. They have tutorials. They have like different cheat sheets or reference pages, all kinds of different resources. Their community is very active as well. And that's a lot of times where people will share the cool things that they've made. Here's a Shiny app that I made. Here's, they talk about packages or package versions. So there's a lot of discussion that goes on there. Of course, Google and GitHub are your friend as well. Sometimes Googling around stuff, people will have their R code in their GitHub account and their GitHub repo. So, I've used some of that to get me started and to kind of figure out how to wrangle some of the data that I've manipulated. So that's possible too. So the R community in RStudio, actually one of our former coworkers works for RStudio now, and they do a lot of really cool stuff. And if you didn't know, R is open source. I think RStudio does have an enterprise version of it. I have not seen too much of that. I've used the community edition of that, but you can just do so much with R, and there's so much community involvement there that there isn't really much you can't do with it.